Record. Now, at school, we sort of finished differentiation, but towards the last part of this chapter, I didn't give out any homework. I don't know if you have enough practice just from the classwork. I guess it's not enough. It's never enough. But anyway, because the next chapter is still about differentiation, although the application of differentiation, but you will be doing differentiation a lot anyway. So I guess that will be another kind of exercise later. But before we enter into chapter 6, I also want to mention the existence of this book from your textbook. There is another separate chapter called Exam Focus 3. And quite a lot of exam type questions are in there. So today, the first half of the lesson. There are 2 examples in this chapter. One example is first principle, find a derivative. Now, I think I have touched on this topic a lot, so I'll leave this to you. You can read it and then do the exercise. The second one is a new type of question. I don't think we ever talk about this one, because if you read it, you can see the function given is implicit function. We have learned implicit differentiation, but this question is new is because I am doing the second derivative on the implicit function. I don't think we've done this before. During the lesson, we explained how to differentiate, find the first derivative of implicit function. We also practice second derivative on explicit function. We never do both in one question, implicit and also second derivative. Now I'll take this opportunity to show you how this is done. X, y squared cosine y. X equal y squared plus cosine y. Now, this can never be changed to an explicit function, so you have to always keep the implicit going on. So first, ddx x equal ddx y squared plus ddx cosine y. On the left, it's 1. On the right, said a lot of times, a function of y, so ddy, ddy, and then dy dx. This one also function of y, so ddy, dy dx. Okay, so after this, the first derivative is found. Okay, Now you pay attention, the answer for the first derivative is still implicit as it has y in it. This is implicit. But you cannot do anything about it. Even if you want to change it to x, you cannot. It's not easy. It's not easy. Now we're going to do the second derivative. Second. So I'm going to put d dx on left and the right hand side again. So I'm going to do d dx, dy dx equal d dx 1 divided by 2y. Okay. So again. Now when I do it again, on the left, I have d dx, dy dx, and that is the second derivative. This is d squared y dx dx. That's dx squared. I think last time someone asked me, why isn't it d squared x squared? I said, I think that you must understand dx is one symbol. Dx means one symbol. So it's dx, the whole thing squared. But we just don't put the bracket there. So it's d, and then y, and then dx, dx. That's dx squared. So this is the second derivative on the left. On the right-hand side, how do we differentiate? Now, first, you must realize this is a function of y. This is a function of y. And d dx doesn't work on a function of y. I will change it to d dy. And then times dy dx. Okay, so my next thing to do is d high, low, minus d low, high, divided by low squared. Times dy dx. And this is equal to, this is 0. So -2 plus cosine y and 2y minus sine y bracket squared. Okay, that's this part. And this part, dy dx, you don't worry because we have found it already. So what you do is you do not leave dy dx there. You will copy the answer of dy dx and write it there. And then your final answer is -2 plus cosine y divided by 2y minus sine y bracket cubed. Is that okay? So that's the end. That's it. Do you have any question? If you don't, I'll give you 1 minute to write this down if you need. Okay. Now, girls, also you can look at the marking scheme. 1 mark is given to successfully differentiate. That's the 3rd line. 1 mark is given to successfully differentiate for the 2nd time. And then the final answer. Let's try another one. There are a few questions like this. Now, question 2 and question 3. Let's do question 2. X equals sine y e to y. X equals sine y plus e to y. Again, ddx x equal ddx sine y plus ddx e to y. And then this is y, ddx sine y, cosine y, dy dx. I'll just write y prime, okay? This one, ddx e to y. That's ddy. So e to y times 2 dy dx. Get this. This is 1 mark. You have to do this line correctly to get the 1st mark. Now with these 2 implicit differentiation, you both have to do ddy first and then dy dx. And this one, ddy itself, is a composite function. Now I can solve for y prime. Y prime equal 1 over cosine y plus 2e to y. Okay? Now the 2nd time. 2nd time, again, so ddx, again, y prime equal ddx 1 over cosine y plus 2e to y. Okay. On the left, it's y prime prime. On the right-hand side, again, a function of y, so I do ddy first. D high, low. Minus d low high divided by low square. Now remember, I'm doing ddy now, so I need to multiply dy dx. So I multiply y prime. Okay, and then simplify. This is 0. So positive sine y minus 4e to y divided by bracket cosine y plus 2e to y squared. And then also copy the answer from y prime. The final answer, sine y minus 4e to y divided by cosine y plus 2e to y cubed. Okay, both the first derivative and the second derivative Both are implicit functions. Okay. Now you will try. I already explained two examples. They look similar. They look similar, but I cannot guarantee they all look the same. So you will try. You will try. From the textbook, there is this question, question 3. Now, why don't you practice and let me know if you are done? Meanwhile, I will show you all the answer. I will show you the detailed answer later. When you are done, let me know. Let me know, please. Question 3. Okay. Now only 5 students haven't finished, but I'm going to show you the answer now. Now I will point out where you might make mistakes, okay? First here, +0, right? And then the square, sometimes you miss the square. Now the second derivative. Second derivative, where do you make mistake? Now the d high has this. Some students will miss this one because this is 2u du dx. You cannot miss out du dx. Oh, sorry, this is y. But you know what I mean? It's a composite function. So it's 2u du dy. 2u du dy. And then multiply. And then this one, d low. It looks like I haven't done any differentiation, but I have. This is because for the exponential function, the differentiation, after the differentiation is done, the derivative function looks exactly like the original function. So that is the derivative there. It's not the original, it's the derivative. The low high divided by low square. And then with the simplification part, you need to take out common factor. And this is a skill I emphasized a lot during the past few weeks. I said, oh, you have to learn how to simplify. If you expand, you can never go back. If you expand any of the brackets here, you can never go back. So do not expand. Take out factors and then it gets simpler and simpler. In the final answer is factorized. And each factor is simplified. That's it. That's it. One exercise during the lesson. I think you will do some homework, but I don't know. I'm quite busy these 2 weeks. I think you're busy too, but we will find time do some exercise. That's all. That's all. Look at the textbook. The other exercise are first principle and this. Now this looks difficult, but this is explicit. So I think we've done this. I think we've done this. And then question 12 is logarithmic differentiation. That's all. That's all. Look at the new notes, chapter 6. Orphan. Applications of differentiation. So we've learned differentiation, but what is differentiation for? So many different applications. This chapter is also very long. First application, geometric, used in geometry. Tangent to curves. I think because we learned tangent to circles, this concept I don't count as new. So I'll just mention these terms. First, tangents. Tangent is a straight line touching a curve at a certain point and only have one intersection with the curve. Okay. The point of contact is this point. Last one, the normal. We also mentioned normal, didn't we? I don't know. I don't remember. Anyway, a normal is also a line that is passing through the point of contact, but perpendicular to the tangent. This line is called the normal of this point. Okay? Normal is a noun. How to find tangents? We have a curve. We will find the derivative at point x1 and then write the equation of the tangent according to the point slope form. This is the point slope form. Y minus y1 divided by x minus x1 equal to the slope of tangent equal to the derivative at x1. Example. For each of the following, find the equation of the tangent of the curve at point P. Tangent at P. This phrase. Tangent at P. It means P is here. That's P. P is on the curve, and there's a tangent passing through P. So, first, dy dx. Okay. Simplify a little bit. I don't have to simplify to the fullest. As you can see, this is not simplified. To simplify, I have to take out x squared minus 5, but I'm not going to do that because I don't need the derivative function. I only need the derivative when x equal -1. 1 minus 5 plus 4, 1 minus 5 equal 16 minus 16. Am I crazy? Equals 0. That's fine. Equal 0 is fine. Because when the slope equal to 0, that means the line is horizontal. Therefore, the equation of the tangent at P, -1, -16 is y equal -16. Look at the graph. In the textbook, you don't have the graph, but I think the graph can help you. So I drew the graph for every question today. Now you see this is the curve, and P is at this point. Now there is P, and the tangent is horizontal there. And the tangent is y equal -16. Another example. This one is implicit. I always have explicit and implicit now to see. It's the same. That's the same. The concept is the same. Obviously, the difficulty is different. So ddx on both sides. Right-hand side is 0. ddx 0. So this one, this is a mixture. Remember we said a mixture of x and y. So it's not so simple. It's product. Product. And then for the second part is just y. So you don't have to do product. Okay. And then we can find dy dx. Okay. As you can see, it's not simplified. But in this case, again, I don't have to. I don't have to. So dy dx. Now for this derivative, I need to put in both x and y, not just x, x and y for 1. So -1, 1 over times 4 plus 3. Right? Put in x and y at the same time. But for explicit functions, there is no need. You only need 1. So the equation of the tangent at P for 1 is y minus 1 equal -1 over 5, x minus 4. And then I simplify 5y minus 1 equal -x plus 4. And then I get x plus 5y minus 5 equals 0. Now you give the answer, the general form, the answer. And also to help you understand, I plot the graph. This is the curve and P is there. And there is a tangent there. Now in circle, it doesn't happen like this. You see the tangent looks like on the left, there is something on this side, and on the right, there is something on this side. Okay, maybe I didn't draw very well. I didn't draw very well. I'll draw better. Like that. Is that okay? I just don't draw very well, but you know there is a line there. Any question? Yeah. -9. Why is it -9? What's -9? Oh, you mean this? Oh, sorry, I made a mistake. I thought so. Sorry. -5, right? And -9. Sorry, -9. Yes, -9. Yes, I made more sense this way. This -9 here, passing through 9. Now, like I said, in circle, you don't have this, you don't see this because circle, the circle will not pass through the tangent. But with other curves, it's possible. This is also called a tangent. Okay. Moving on. Yes. Yes. Now you do it. You do it. One is explicit, the other one is implicit. Okay. Now, this is the answer for A. And you can see on the graph at P, there is a tangent line like that, like that. And also for part B, again, it's implicit. On the left, it's a mixture of X and Y, so I have to point this out again. Now, the part I'm highlighting are derivatives. So F prime G plus F G prime. So this is the tangent, and on the graph, there is a tangent like that. It should be consistent with your answer. Okay? Moving on. Example 2. In example 2, you will see part of the condition is taken away. Let me read it. Consider the curve and find the equation of the tangent to the curve, which is parallel to the line L. Now, what do I mean by that? I think I mean that, on the curve, there are a lot of tangents, but one of them must be parallel to given line L. This line given y equal 9x minus y equals 3. This equation of L. So where is that? Now, if the curve is given to you, I think you can kind of guess that there may be a line that is here, parallel to L. Sorry, I didn't draw it very well. But maybe somewhere here. Okay, parallel to L. And at some point here, but unknown, unknown. So our target here for this one is to find the point of contact. Now, in example 1, the point of contact is given. Now, for example 2, the point of contact is not given. However, the slope is given. The slope is given. So first, the slope of the tangent is equal to the slope of L, which is equal to 9 in this case. Now we know the slope is equal to 9. And we need to assume the point of contact is X and Y. Now to avoid confusion, I'm going to use X0, Y0. Let the point of contact be X0, Y0. And we're gonna set up equation to find X0 and Y0. First, dy dx equals 3x squared minus 6x plus 0. Okay. And we can set up equation now. That is dy dx at x equal x0. That is 3x0 squared minus 6x0 must equal 9. Right? At this point of contact, the derivative must equal to the slope. So I have derivative equals slope. And then I can find x0. This is a quadratic equation. I will solve it. I have two solutions. How to understand there are two solutions? I think it's also very clear because the graph is given. Now you can see there are 2 points. Both here and here. Here 3, here -1. Both have tangent parallel to L. So let's find out these two. When x0 equals 3, y0 equal, I'm going to use the curve to find y0. So y0 equal 3 cubed minus 3 times 3 squared plus 5 equal 5. Then the equation of the tangent is y minus 5 equal 9 times x minus 3. And that is 9x minus 5 minus 22 equals 0. That's the first one. For the second one is when x0 equal -1, y0 equal -1 cubed minus 3, 1 plus 5. That is 1. The equation of the tangent is y minus 1 equal 9 times x plus 1. So 9x minus y plus 10 equals 0. There are 2 answers. Now, how many answers there are depends on the curvature of the curve, right? If this curve has more waves, then maybe even more. But for this curve, only 2. Yeah, you can do the classwork and find out how many there are. Pay attention. In the classwork, the equation, the tangent is perpendicular to L, not parallel, perpendicular to L. Okay. Now you can look at my answer from the left. First, I find out the slope of the tangent. It's -2/3. And then I set out to find the point of contact. Okay. And then the point of contact is at x0 equal -1/3. Now to find the equation of the tangent, I still need the coordinate of the y coordinate of the point of contact. So I substitute 1/3 into the original equation of the curve. The value of y is 23/9. And finally, the equation of the tangent according to the slope point form is y minus 23/9 equal the slope times x minus 1/3. Simplified, 6x plus 9y minus 25 equals 0. On the graph, this line is tangent to the curve at 0.3, somewhere here. And then tangent to the curve. Now on my graph, these two lines don't look very perpendicular. This is because my scale is skewed. You see that 1 unit on the x-axis is much longer than 1 unit on the y-axis. So this graph is not drawn to scale. So it doesn't look very perpendicular, but it is. Do you have any question? You check your answer with me. Okay, we're going to the last example now. Last example today. The last example, I think the difficulty also raised very rapidly. Let's read it. So consider the curve, it's a quadratic. So quite good, quadratic. The two tangents can be drawn to the curve passing through 2, -1. Now you see the phrasing here. The sentence here is very different from example 1. Example 1 says, not very different, perhaps very similar, but I think it's very different. In example 1, it says the tangent at, okay? Tangent at. That means the point is on the curve, you're going to find tangent passing through that point. But this one, you don't see tangent at, you see tangent passing through, The tangent at and tangent passing through, these two phrases, you must distinguish because one indicates that point is on the curve. The other one says the point is not on the curve, like in the figure. You see, the point is not on the curve. So I don't say the tangent at. I don't say tangent at. I say tangent passing through. And there are two tangents passing through 2, -1. Let me show it on the graph for you. One line looks like this. Oh, it's not very well done. One line looks like this. Oh, it's not very well done. One line looks like this. The other line looks like this. I don't draw very well. But anyway, you know what I mean. So these are called two tangents passing through 2, -1. Okay? Now how to find these two lines? I say the difficulty increases rapidly because right now we don't have the point of tangent. Sorry, we don't have the point of contact, like example 1. And we also don't have the slope of the tangents, like example 2. So for these 2 lines, we only know they pass through 2, -1. We know nothing about the slope and nothing about the point of contact. But somehow we need to find the equation. I'll give you 3 minutes to absorb and think about it. 3 minutes may not be enough, but after 3 minutes, I'm going to explain 2 methods to you. One without differentiation and one with differentiation. 2 methods. Okay. I think it's more than 3 minutes. First method. Method without differentiation. Let the equation of the tangent be y minus -1, that's y plus 1, equal k, maybe not k, but m, times x minus 2. Now this is because I know the tangent passes through 2 -1. And I just don't know what the slope is. So I let the slope be m basically. So the equation can be written this way. And I will simplify to the slope intercept form. Slope intercept form. Because later on, I'm going to substitute this equation of the straight line into the equation of the parabola. Substitute y equal mx minus 2m minus 1 into y equal x squared minus 6x plus 11. We have mx minus 2m minus 1 equal x squared minus 6x plus 11. Okay, now I have an equation in x, but it's not in the best form. So x squared minus 6x minus mx plus 2m plus 12 equals 0. Then x squared plus -6 m x plus 2m plus 12 equals 0. Now in the general form. Now because the tangent touches the curve at one point, therefore the equation this equation has only one real root. Therefore, delta equal -6 minus m squared minus 4 times 2m plus 12 must equal 0. Okay. I think you have seen this before, but maybe not here, and also not a straight line and a parabola, but in chapter 7, a straight line and a circle. Well, we use a similar method. So 36 plus 12m plus m squared minus 8m minus 48 equals 0. And m squared minus plus 4m minus 12 equals 0. And m equal 2 or -6. Therefore, the tangents can be found y equal 2m minus 5, or 2x, sorry. 2x minus 5 or y equal negative 6x plus 11. And this method, I think, as a revision then, because of the test is next week. Is that okay? You see the whole process, I don't have to use differentiation. It's very clever, isn't it? In chapter 7, the equation of the circle used a similar method. We also have another method in chapter 7, which is the geometry method. But here we have no geometry. We know nothing about the parabola in geometry. So that is one. That is one. Method 2. Method 2 is differentiation. Now to differentiate, I need to know the point of contact. Now you see, for this method 1, I didn't care about I didn't care about the point of contact. In the end, I found the equation. I know nothing about the point of contact. If I want to, I can resolve the equation to find the point of contact, but it's not necessary. But for method 2, the differentiation method, I have to find the point of contact, because only through the point of contact, I can find the slope. Let the point of contact be x0, y0. Okay. So I don't have m. In this question, I don't have m. Now, derivative. dy dx equal 2x minus 6. I think that's the differentiation. The differentiation part is done so quickly. So quickly. But how to use it? Wait. I have a message. I need to read the message. May I ask why y1 can be used on point? What? Just okay. May I cannot answer you right now. I cannot answer you right now. What? Let me ask the whole class then, before I go into method 2, because I received this message from May, and she asked me why the equation of the tangent is this. Why the equation of the tangent is this? How do I answer you?
Sorry, Ms. Chen, I may need to clarify myself a bit because I'm just a bit confused because I thought this equation of tangent can only I mean like the x1 and y1 which is used in this equation must be a point on the graph, but not just any point on the line of the tangent. Sorry, am I wrong on that?
Are you wrong? You think that this equation can only apply when 2, -1 is on the curve. Is it true? Because this equation, girls, this equation essentially is the equation of straight line. Essentially, you can use any point on the straight line and the slope to find the equation, to write this equation. You don't need a specific point, let's say the contact point, to write the equation of the straight line. Okay, that's my answer. So if you think that 2 and -1 must be on the curve, it doesn't have to. It basically can be any point on the straight line. You also write the same equation. That's what we agreed on last year. When you write 3, 5, slope equal 4. This straight line, when I write the equation, I write y minus 5 equal 4 times x minus 3. And there is no curve involved. I think this can be confusing. It can be, because on the previous page, I mentioned, oh, you write the equation of the tangent, and then you need the point of contact, and you also need the slope. Yes, yes. Now, if 2 and -1, 2, -1 is the point of contact, this is the tangent already. Yes, but if 2, -1 is not a point of contact, it's fine. It's fine. The equation of the straight line is still this one. It's just now, because missing the point of contact, m is unknown. You know what I mean? I think not just her. Maybe some of you are confused by this as well. not just me. Some of you, but she is very good. She shared with me, and I can clarify this. I never thought this could be a problem. Yes, I just said, and I contradict myself. Yes, but you understand that I find any point on the curve, I can write the equation. It's just I don't know m. Let me know. Let me know. Because do you see? Yes, yes. We have to carry on now. Carry on now. If you have a similar question to this, let me know. Okay? But I insist that the equation of the tangent can be written this way, although 2, -1 is not on the curve. Method 2. Method 2. Method 2. Derivative is found very quickly. Derivative is found very quickly. But without the point of contact, even if I do the substitution, I can do the substitution. I still cannot find the slope. The slope has x0 in it. Just, it's unknown. It's unknown. So I have to find a way to set up equation for the point of contact. Now, how do I set up the equation? First equation. The first equation is the most obvious, but somehow is usually missing by students. The equation is x0, y0 satisfy the original curve. Y0 equal x0 squared minus 6x0 plus 11. That's my first equation. You say, oh, it has y in it. It's fine. I think my goal is to set up enough equations so everything can be found. And my first equation is y0 and x0. They satisfy the original curve. Most obvious, but often missed out. The second equation is very hidden. The second equation is very hidden. The second equation has to be set up through the slope equals slope. So watch out. Watch out. So the slope of the straight line, slope of the tangent, is equal to 2x0 minus 6. That's the value of the derivative. Also equal the slope of tangent. Slope of tangent. On the right hand side, I'm also going to write slope of tangent. But this slope of tangent is through the definition of tangent. y0 minus -1, x0 minus 2. You see, it's like everywhere. In these two equations, I used everything I know about this curve. First equation, explained already. Second equation, look. On the left, the value of the derivative. On the right is the definition of slope. Now, what's the definition of slope? That's y minus y divided by x minus x. It's the most unusual one because you used it 2 years ago. In S4, some of you already hate it. Some of you already don't want to use this one. But it's still there. Still there. The definition of slope. Now, with these two equations, I can find x and y simultaneously. And after I found x and y, and now I'll find the equation. Now, solving. y0 plus 1 equal 2x0 minus 6 times x0 minus 2. That means y0 equal 2x0 squared minus 6 minus 10x0 plus 12 plus 11. Okay, put them together. Okay, I don't want them to be wrong. Let me see. Why is it plus 11? 6, 2x minus 6, 2x minus 6, minus 6 minus 4 minus 10, plus 11. Huh? Huh? Anyway, x0 squared minus 6x0 plus 11 equal 2x0 squared minus 10x0 plus 11. That means x0 squared minus 4x0 equals 0. I will have two values. Okay. And then when x0 equals 0, y0 equal 11, dy dx at x equal 0 equal negative 6. The equation of the tangent is y equal y minus 11 equal negative 6 times x, y equal negative 6x plus 11. When x0 equal 4, y0 equal 4 squared minus 24 plus 11 equal 27 minus, that's 3, and dy dx at x0 equal 4 equal 2 times 4 minus 6 equal 2. The equation of tangent is y minus 3 equal 2 times x minus 4. So y equal 2x minus 5. Okay, same answer. Is that? Now to solve this using differentiation, you see the differentiation part is not difficult. You only differentiate in 1 second, but you set up the equation. And solving the equation takes longer. And you will try because 15 minutes left, you try the last part and then we're done. Example 3. Example 3. Use either method then. Use either method then. But for M2, it's method 2. Okay. Okay, this time you did faster. And I only show you the method 2. Now you may ask me in the compulsory part when I need to find the tangent, can I use method 2? I think you can. I think you can. Now method 2. I differentiate, but that's not useful. It's not useful enough. Differentiate. I substitute, also not very useful. Now some students like to do the substitution and differentiation in one line. I do not recommend that. For me, I think one is a function, the other one is a value. They should not equate each other. Okay. And then set up the equation. Set up the second equation. Please mark this down. If you don't know how to set up the second equation, remind yourself how to set up the second equation. And then solving the second equation. Now this part you can shorten it. You don't have to write this long. Anyway, you will have 2 solutions because of the curvature. The tangent, you do have 2 tangents passing through the same point. I think in the compulsory part, we call this tangents from external point, right? There is one lesson called tangent from external point in geometry of the circle. This is also tangent from external point. So 2 of them. And then how to present your answer. When x0 equal -2, what is the value of y? What is the value of the derivative, i.e. the slope? And what is the tangent equation? Also, for another value, what is the value of y? What is the equation? Sorry, what is the slope of the tangent? And what is the equation of the tangent? That's it. That's it. This you will do homework, okay? So that's all. If you don't have any question, you can leave. Bye-bye.